Okay, so this is the third example for solving separable differential equations with initial conditions of first order. So we got a first derivative given here, and it's x times y over 2. That's what the derivative is given. The question is, again, this is the question that we've been solving here for the other examples as well. Find the particular solution y equals f of x to this differential equation with initial conditions f of 1 equals 1. Okay? All right. So let's deal with this here. This one is going to be probably the more challenging of the three that you've seen so far. So separable. These are separable, aren't they? We have dy over dx, and we have x and y. Now x and y are multiplied together, but we can separate them by dividing. We can divide an x off or a y off, whatever. So I'm going to bring this dx up over here to this side. And I'll do one step at a time here for you. Okay, so that dx, I can move that over. We discussed this already. It's sort of like a bit of a ratio. You can manipulate this a little bit across the equal sign. And the y now, I got to get the y over to the other side. So we can divide now by y. All right, divide both sides by y, and you're going to get 1 over y. And this 2 over here, and then you can do what you want. You can leave that over here as a 1/2 or whatever. So I'm going to write that as a 1/2 x dx. Okay? So does everyone see how now we've separated that differential equation? Okay? It's separable. We can separate it fairly easily. We don't have to take any square roots or do anything really crazy. All right? Not that that would be a serious problem, but it's pretty easy to separate. Okay. So now, as our habit here, we now take the derivative of both sides, right? We're going to take the derivative of the y, because this function is in terms of y, and it's with respect to y here, right? So this is good. So what is the antiderivative of 1 over y? Anybody remember what that is?
Ln x.
Well, it's close. Not ln x, it's ln y, because it's a y variable. But yes, it's natural logarithm. Very good. Okay? And over here, what do we have? Well, we have 1/2, and this is a constant. You could bring it out if you want. But anyways, this is up to the 1, so that's times 1/2 x squared. Okay? Plus what? C. Okay? And we've discussed already, you can roll the two c's from either side, roll them into one constant, and just show it in one spot. It's going to be much easier. It's a combined kind of super c. All right? No problem. All right. So, do I go ahead and I solve for y now, or should I solve for c first? C first. Good. Don't beware the late c. So we've got x equals 1 and y equals 1. And so let's do that real quick. Now, ln of 1 equals 1/4 1 squared plus c. So our c is going to be negative 1/4. What is ln of 1 though?
0.
Is it? Okay, so e to the power of what equals 1, 0. Yeah, so that's 0. So everyone good with that c equals? Okay. So what I'm going to do again, just to save some time, you guys can leave your work there, please. But I will just erase this, and I'm going to put that negative 1/4 right here. Okay, so minus 1/4. We're all on the same page here so far? Okay, so we'll combine this 2 to 1/4. Okay, so now I have to solve for y. How do I get rid of ln? Do I just divide both sides by ln? Okay. Yes. So what you want to remember is that ln of y is the same as logarithm of y base e. And if we have a logarithm equation, you can always rewrite a log equation as an exponential equation. And so we understand how this relationship works. The base is e. This is the exponent right here. And it equals this value here. So in order to rewrite this as an exponential equation, we go e to the power of 1/4 x squared minus 1/4 equals y. Okay, that looks a little funny, but we're on the right track. Now the other thing you might want to do, I think in your textbook here, I looked this answer up before, I think in your textbook here, it doesn't show this like this. It kind of factors the 1/4 or brings them into one number there. So it looks like this. Now this is both 1/4, so it's really, they write it as x squared minus 1/4. Okay, as an exponent there. Okay, if you brought a 1/4 out and just multiplied that by x squared minus 1, that'd be fine too. But anyways, that is the answer to this question. Okay, and if you took the derivative of this, you should end up with this as the derivative.
Pardon me?
Yeah, so if you took the derivative of this right here, you would end up with this right here as the derivative, what you're given. Because remember, this is just the antiderivative, y, or the integral. And it's the particular antiderivative for this derivative. Right?
Where's E?
E is right here.
In the derivative?
There's no e in the derivative. No.
Can I ask you how come?
Okay, so good question. Let's go back to that original question. Here's the function, and the derivative looks like this. But the question was, where's the e? How come there's no e in the derivative? Because the derivative of e to the power of something is itself multiplied by the derivative of whatever the something is there. And so what you see is you get this, yes, it's itself, times this, which is a 1/2 x, what this simplifies to. And so the big thing is, and we've done this a few times before in calculus, is where to simplify this is the same as y, right? That's what y equals. So you can substitute this in for y, and then y times 1/2 x is the same as xy over 2. So you do get that as the particular derivative there. Okay? Good question. And I made you all do that work, so that's good. Good for you.
Thank you.
Everybody understand there now? It's a good question.